Welcome, everybody. Love to see all these friendly names in the chat over here. Thank you so much for joining us today. My name is Kalia Garrido, and I head up strategic marketing and events here at Hike2. Hike2, if you don't know us already, we are a fully functional, best-in-class innovation consultancy, and we specialize in digital transformation strategy, human-centered design, cloud, AI, data, the whole gamut of technology projects. So you are in for a treat today as we have a special guest with us, one of the smartest futurists that we know, who is ready to share his expertise on the redefinition of work, human thinking in an AI-enabled world. But before we begin, a few housekeeping notes. This is, of course, a webinar, so your cameras and microphones are all off, but we do encourage engagement via the chat, like Gary has already kicked off for us. You can also use the Q&A, and we'll reserve a little bit of time at the end of the session if you feel like asking a question live. We are, of course, recording, so this session will be posted out on our YouTube channel along with a plethora of other innovation-forward content, and I'll share the link here for that soon. And of course, we have an exciting announcement. Our Innovation Summit, it's our annual marquee event. It is happening next month, at the end of next month, March 25th and 26th in Pittsburgh, Pennsylvania. This is our annual event. I'm going to share the link for you all in the chat here soon for that as well. And we are excited to kick off the Innovation Summit unofficially with this webinar today. So allow me to introduce Amanda Wadzensky. She's the co-founder and principal at Hike2. Prior to starting Hike2, she spent about 20 plus years in the CRM and technology leadership space, and much of that was focused on the Salesforce ecosystem. She focuses now on cross-functional solutions that blend strategy, governance, and human experience with technology to help organizations drive real transformation. And that's the end of my spiel. With that, Amanda, please do take it away.
Awesome. Kalia, thank you so much. And I'm so excited for this conversation that we're going to have with Peter today. I first met Peter years ago at a small conference in Philadelphia and was an immediate fan. I look to Peter as a mentor, and I follow him always. I'm so fascinated by his views into the future and how we should be thinking about the bigger picture and really how it relates to the entire world that we live in. Most of us know Peter from his time at Salesforce when he held the title of VP for Strategic Research. But now I'm really intrigued and looking forward to following him on this next adventure. So Peter is currently the president and co-founder of the Foundation for Intelligent Life on Earth. This is a Seattle-based nonprofit supporting research, fieldwork, education, and advocacy for climate change mitigation, environmental stewardship, STEAM education, and the exploration of Earth and space. So what could be more exciting than that journey and following him along that? So Peter, thank you so much for joining us again this year. We love having you join us to unofficially kick off this summit. And I think,
it's great to be with you all. Thank you.
Yeah. Oh, you're so welcome. And just, what a moment in time it is. The world is moving at the fastest pace that we've ever seen it move. There is so much uncertainty about what our world is going to look like in a few years. What is it going to look like for ourselves? How are we going to work? What does this mean for ourselves and for our children? As Kalia mentioned, each year we at Hike2 host our Innovation Summit where we explore what's next. This year we're going to continue to dive into the future of work and how work will be redefined. So really excited today to have you kick us off and share your perspective on this.
Thank you. Thank you. Yeah, the comment, things are going so fast always reminds me of the comment from the gentleman at Intel who said, yes, but do try to appreciate this is the slowest it's going to be for the rest of your life. Whenever you think that a hockey stick curve is about to turn into an S curve, the next hockey stick overlays on top of it. And so what has been happening with Moore's law rates of improvements becomes at some point what happens with quantum becomes, I don't know what comes after that. And the important thing is, I believe, twofold. One, what's different this time? What's genuinely different this time so that doing the old thing better, faster, cheaper is no longer a definition of success? But at the same time, what has not changed? What are the lessons that got learned at least once expensively in the past that we shouldn't have to learn all over again? But the conversation now is different. And so we're going to be talking about, to some extent, talking about AI, but really also talking about the processes and the contexts that make it, worth the candle. And I appreciate that you guys gave me the title for this session, because the talks I do that are most interesting to me are the ones where someone else told me what the title was going to be, and then I have to say, oh, okay, well, what do I think about that? And so this phrase redefinition of work really did trigger a lot of what you're going to be seeing from me. But the first thing I want to observe is something that I just ran across last month, when someone said, well, what is a learned person in a world where machines can learn? A machine that has learned and a person that is learned probably are not the same thing. And this is a phrase that I got out of a comment on Medium, where we always used to know what a learned person was. You've got a high IQ, you get great test scores, you have specialized knowledge, and so you're going to have a great job. And so you hire smart people, and we treat intelligence as scarce. But Jensen Huang at NVIDIA has said intelligence, what we used to call intelligence, is going to be like tap water. If it's not good, you'll notice. When it is good, you won't think about it. It's going to be a utility. It's going to be available to anybody. And so the question, and this is not the answer yet, but this is the question, where does human value hide? And that's not the verb I probably would have chosen, but I think it's a good one. What do we have to look to see that we may never have noticed before, that represents the human component of value that is amplified by what's being called AI, rather than being subordinated to it, rather than being made inferior to it? We can start by asking, well, how come AI now is being talked about with a level of intensity that was not in past so-called AI winters? Because remember, we're coming up on, it was 71 years of conversations about something called AI that originally was thought to be essentially a summer project for 10 people over a summer. I said, oh yeah, we got the hardware, we got the code. We just need to think about how do we represent the kinds of things that humans do. And what they discovered over the next 1 or 2 decades, and you can read the comments from some of these same people, Marvin Minsky in particular, was very good about saying, oh yeah, this actually turns out to be really hard. For one thing, they were totally off on whether they had adequate hardware. This was being sold as an AI workstation in 1985, 30 years after that famous Dartmouth memo. It was $15,000 in 1985 money, which is more like $60,000 now, for something that you wouldn't even be able to sell as a keychain fob today, with 4 megabytes, not gigabytes, megabytes of memory, 45 megabytes of hard drive. This was being called an AI workstation, and it simply wasn't capable of doing more than what one might call toy demos. But even if you had the money for the kind of hardware needed to do anything more meaningful, it turned out that when you actually put a knowledge-based system into production, you wound up with success stories. And I will stress this was a success story for Digital Equipment's XCon expert system that configured VAX mini computers over a period of 7 years, which is a long time for an AI project to remain in production as an actual working tool. It became 6,200 rules, half of which needed change. And the idea back then was that, well, you will have these people called knowledge engineers. They'll interview human experts. The human experts will explain how they do what they do. The knowledge engineers will encode that into rules. An inference engine will take the rules, turn it into an expert system. And almost every single part of that turned out not to be as easy as they thought. Experts are terrible at explaining what they do. It's often difficult to encode, and the manual effort of maintaining that rule base was so great that a year after the conference where they presented this tool, they showed up looking pretty battered and bloodied to show the knowledge maintenance tool they'd had to build to keep the system functioning, which they said turned out to be a far more difficult task. So what's actually different now is that instead of being bottlenecked by the hardware is far more abundant now by factors of millions. And instead of being bottlenecked by human encoding of the knowledge, we have systems that can learn. But here's something remarkable, and look at that date at the bottom of this screen. In 2017, Google was working with their machine translation. You've probably used Google Translate at least once. It's pretty darn good. And you had, English to French, French to German, the usual pairs. But if you wanted to go from English to Tongan, you might have to go from English to French and French to, Creole and Creole to Tongan or whatever. And it got pretty bad. But they plugged in a neural machine translation system and gave it success criteria. And without being told to do this, I want to stress this, something that had been sort of an idea of linguists for decades, it evolved on its own. It evolved its own universal language. So going between any two languages was language A to universal language to language B. It did this in weeks. This is, in my opinion, one of the seminal moments when we said, hey, wait a minute, telling the machine what to do may no longer be the pathway. Telling the machine what we needed to achieve, what accomplishments we needed to produce, and then turning it loose on the problem may actually be a viable way to get stuff done that we don't know how to do and don't know how to tell a machine how to do it, but that the machine may be able to evolve its own mechanisms given the time that it has. But what this does is ask the question, okay, so if machines do this, then what is it that we do? This is something that Brendan McCord talked about, where he said, people that we call scholars are people who can navigate libraries, write a great essay, and answer questions. Well, we have machines that do that now. And so the question about, well, what is scholarship? And he says, the thing is, I'll talk to my best students and I'll say, so what did Mill say about the harm principle? And they'll tell you. Well, how do you feel about that? And they'll start comparing other people's critiques of it. But he says, you realize that getting them to express their own thinking about it is not something that spontaneously comes to them. It's not what they've been trained to do, not what they've been schooled to do. They've been schooled to be able to summarize all the arguments that other people have made and compare and contrast those. And it used to be people who could do that fluently, on demand, were regarded as really incredible resources. Yeah, but AI does that. Okay, those are things that now get done, as Brendan McCord says, faster, smoother, better. I took a corpus of 130,000 words that I'd written on the subject of competitive strategy over a period of years, threw it into a generative AI, and asked it a question that I did not have in mind when I wrote it. The essays were written for our internal teams on how to sell what Salesforce produces. I asked it the question, how can an independent practitioner make best use of what Salesforce offers? Not the question that text was written to answer. And it produced a beautiful 12 bullet point list with some explanatory notes that I was able to turn into a keynote speech in a matter of hours that probably would have taken me days to do without. And that was an important moment for me. That was when I said, okay, this stuff is able to do things that are huge productivity improvements. So, title slide said that this was going to be a talk about redefinition of work. So let's talk about some redefinitions. Number one, the word data is almost always misused. People use the word data as if its roots had something to do with fact or record. But if you actually check, the etymology of the word data literally is a thing given. And I ran across that when I was writing a chapter for the Rutledge Handbook of Information of Risk and the Law, when I wanted to have the chapter on information risk, and I wanted to talk about, well, what is data? And I looked at this, I said, I didn't know that. I assumed I was going to find something that had to do with, fact or reality or truth, and said, no, it's a thing given. And that was an epiphanic moment for me, because I said, until I've collected it with intention and purpose and given it to someone for a reason, it hasn't matured from being an observation to being data. Data is like something that something graduates to in the process of my putting it together and handing it to you with some purpose in mind. And if you don't know why you're collecting it, if you don't know why you're giving it, almost by definition, you are not dealing in data. You are just dealing in stuff, bits, if you will, because that brings us to another word that's almost always misused. The word information is used as if it's a mass quantity. That wasn't always the case. The verb to inform existed long before we talked about information as something that you could measure in bits. The act of information, it was a verb and it was an accomplishment. You informed someone if you gave them a new understanding of the situation. Someone said, the equations of fluid dynamics inform the design of boats, for example, as an example that Neil Stephenson used in one of his books. And if you think about that again, it's kind of like data. I give you stuff for a purpose. The purpose is to achieve a moment of information when in your mind, your understanding of what is happening or what is going to happen, or maybe what has happened, although that's less interesting, often it's less important than people think it is, before it got petrified into bits. Oddly, when Norbert Wiener and Claude Shannon first started talking about bits, it was regarded as sort of an amusing eccentricity. It was as if I had told you I was going to find a way to measure poetry. People said, what are you talking about, a measure of information? Information happens in people's heads. Well, the pendulum has swung so far that now we act as if information was always about piles of bits and not about the accomplishment of helping someone understand something differently than they did before. Which brings us to another word, which is intelligence. We talk about artificial intelligence. We talk about intelligence as if it's cleverness in putting facts together and seeing things about them. This is why the guys in 1955 thought they could do this over the summer, is that they noticed that people generally find it difficult to do that, and people who do it really well are called intelligent. And so they thought that was going to be the hard part. Well, it turns out that inductive and deductive reasoning and pattern recognition and other things that clever people do really well are easy to write code to do. Common sense knowledge is much more difficult to do, and giving someone something, data, giving it to them, an act of data transmission to inform them, to change their understanding of the world, and turn it into intelligence is all about the decisions to be made. And you're going to hear more about this from Cynthia Freeland at the Innovation Summit, when she talks about the fact that the NFL draft is about which players do I want? What team am I trying to build? It is very forward looking. It's only interested in what the players did yesterday to the extent that it helps you predict and make decisions about what you're going to do next. And that focus on the athletic field is too often missing in the enterprise. In the enterprise, people say, well, if we just could really understand what we did yesterday and put some percentage growth targets on it and some error bars on the growth targets, then that would be a strategy. No, it is not. It might be a plan. It's not a strategy. It doesn't deal with what will you do in foreseeable but different situations. The impact of intelligence is therefore about how are you presenting it to people who have the capability to make decisions? Are you respecting the limits on what decisions they can make? Are you giving them stuff that they don't have the power to use, in which case, why? To prove your own intelligence, to prove your own value? Data is given to achieve information in an act of enabling better decisions and thereby turning that moment of information into a delivery of what a military strategist would call intelligence. I don't just tell you where the enemy is. I tell you where I think they might go next based on the communications they've been sending. I give you a guide to what's going to happen next, which brings us to another word that's generally misused. If I pointed a pile of rocks and say, wow, look at that big geology, you would regard that as odd. It's not geology, it's just a pile of rocks. If I show you a large space full of animals in cages and say, wow, look at the zoology, you'd say, it's not zoology, that's just a zoo. Okay, if geology is something that I do with the rocks, if zoology is something that I do by studying the animals, then why do I point at a pile of transistors and say, wow, look at that technology? Ologies are disciplines. Ologies are means of study and understanding. So if you think about it, if you're a technology company, you need to be a place where there's a process, a culture of inquiry and experiment that leads you to notice new capability, notice changes in customer behavior, recognize that there are things you could do now that you couldn't do before, understand that people need to have explained to them not only why they want that, but why they shouldn't be afraid of it. Technology is a field of inquiry and practice, and the objects that get produced are the side effect of that. Now at 3M, they used to have rules like 30% of our revenue needs to come from products that we invented in the last 3 years. It's a very high bar to clear. I think that was the number, but it was that kind of thing. What fraction of what you do represents stuff that you've originated within some recent period of time? Because if you're not maintaining that cadence, then arguably you are ceasing to be a technology company and just becoming a manufacturer or a service provider. If you want to be a technology company, you have to be continually maintaining and nurturing a culture of inquiry and experimentation and communication to your customers, delivering them intelligence on what they can do now that they couldn't do before and why they should want to do that by building on an act of information, understanding the world around them in a new way, by having handed them, making it a thing given data that they may not have had before. You get all these things right, and you will be accomplishing the things that make people say, wow, what an amazing company. You will, if you look at prototypes like Apple, for example, which has been amazing consistently over the years at bringing people something they didn't know they wanted until they saw it. Steve Jobs would always say, I don't want to talk about focus groups. Focus groups, you know that they want to take the thing they've got and make it better, faster, cheaper. There is a probably mythical comment often attributed to Henry Ford that if he'd asked his customers what they wanted, they would have said they wanted a faster horse that doesn't eat so much. They would not have asked for a car. They had never seen a car. He probably never said it, but the idea that your customers will ask you for a conceivable improvement to what they already know. Stuart Butterfield talked about this back when Slack was still a little company called Tiny Speck. He said, think about what you're asking people to do. Email by default is one person talking to one person, and everything more that you do with that has to be grafted onto it. Slack by default is one person sharing with whoever's interested. Networks forming spontaneously instead of you having to ask to be added to a mailing list, you can find a channel and join it. It's a massive behavior change. And one of the comments he made was, no genuine innovation has ever failed to ask for big behavior change. And no invention that doesn't ask for big behavior change has ever really achieved the status of an innovation. Innovation is behavior change enabled by technology as a process and a culture, made possible by the possession of intelligence, achieved through acts of information enabled by data. So what are the enablers of real intelligence? When we think about what we're going to do to change ourselves and our organizations, we're going to develop collaboration intelligence. If you are not developing tools that do a better job of helping people break down the silos, if you're just adding AI stuff to existing silos and partitions of your organization, you may be able to do what you do today better, faster, cheaper. You probably won't be able to do novel things. You probably won't be able to respond to new competitive challenges. Collaboration intelligence needs to be constructed. It does not spontaneously arise. Universities are large grassy areas with separate buildings for separate subjects. If you look at the campus at MIT, you'll see a building that was consciously, intentionally designed to be an architecture of collaboration. Buildings that are one massive connected building with flat floors and huge doorways. It was literally designed to be a space in which equipment could move back and forth and people could discover each other's work. It is a physical embodiment of the idea of we're going to construct a collaboration environment. We're going within that environment to give people the tools for context intelligence, reduce the duplication, support the creation of content. Lou Platt at Hewlett Packard once famously said, imagine what we could accomplish if Hewlett Packard only knew what HP knows. What Slack does that's especially amazing is become a fantastic playbook and resource for figuring out what people already do know so you don't duplicate it, and being able to create and share stuff in collaborative ways so that new things can happen quickly. A lot of this has to do with data intelligence, that is to say, being able to find it, assemble it, visualize it, and analyze it. And if you're not consciously developing these tools among people, if they still think a table of numbers is a way to look at facts and hope that they turn into data and hope that they achieve information, then you need to work harder. There are tools, whether they're the graphics in your spreadsheets or more sophisticated interactive things like Tableau, that allow people to have data intelligence operating within multidisciplinary contexts to achieve collaboration. And if you do all this repeatably at scale with consistently improving performance, you can achieve process intelligence, tracking, automation of that which can be automated so that you can use your brain cycles to work on what can't be automated, to work on what has to be novel, resourcing and approval. It's remarkable how many organizations overstudy the problem and under-enable decision and action. There's an expression from air combat called the OODA loop: observe, orient, decide, act. If you have everything focused on decision, but you're not investing in observation, you're not humble enough about the need to continually reorient, to say to you, well, okay, I've just seen something that I've never seen before. I'm not going to try to fit that into my existing worldview. I'm going to ask what's wrong with my worldview that this doesn't easily fit, and fix that worldview, the orientation part, so that I can make decisions and then, of course, crucially, take action. Instead of the action being, oh, okay, I don't understand this, I'm going to go back and study it some more. How about a bias for action where we try something, see how it alters the environment, and have a tight loop? It's called an OODA loop. And the person with the fastest loop generally wins. I want to conclude by making sure that people have adequate respect for the limitations of what this AI stuff can actually do. I have yet to find a better example than this. If you've ever seen a picture of a wristwatch in an advertisement or in a catalog, it was probably showing the time 10:10, because the hands achieve an expression that looks like a smiling face. And this has been psychologically demonstrated to make people feel better about looking at the object because it seems to be smiling at them. It shows off the manufacturer's logo. It's a pleasing arrangement. It's almost universally encountered in the photographs, with the result that when AI is trained on the idea of a wristwatch, almost all the images it has ever seen are images of wristwatches with the hands displaying 10:10. So that when you ask a generative AI for a picture of a wristwatch showing any other time, it has no idea what you're talking about. These are pictures I actually did myself with one of the generative AI tools. Wristwatch showing a time of 3:25. They're not showing 3:25. They're showing 10:10. Why? Because they think that's what a wristwatch looks like, and they have no idea. I'm anthropomorphizing here. They have no idea that the position of the hands has anything to do with the question, what time is it? That's simply not there. They produce an illusion of knowledge, but it's millimeters deep. And as soon as you ask a question that requires them actually to understand anything about what they're showing you, you discover the limitations of that understanding. Now, to be fair, people sometimes have trouble telling time with hands on faces. This is not something that school children learn anymore. And on Jimmy Kimmel Live, they asked a group of college students to tell time from a wristwatch, and one of them said, "Oh no, I can't do that." All right, let's be fair. Let's give the machines the same advantage that we give people. Let's ask them to give us a digital watch showing the time of 3:25. No, they don't do that either. In fact, not only do they not give us 3:25, they don't even give us something that looks like numbers at all, because they're mashing up all the images they've ever seen, saying, "Oh, okay, you want something that looks like this." There's no connection. There's no information happening in that AI. It does not understand that the position of the hands or the arrangement of the digits on the screen has anything to do with the concept of time. It's just not there. And you will, if you look for it, you will encounter this kind of shallowness in many of the systems that are being used today, and you need to understand what they simply can't do. On the other side of the equation is the fact that what we call knowledge is becoming an endangered thing. This is an actual example that was reported by Technology Review a little while ago. There's a Greenlandic language edition of Wikipedia that was added around 2003. There are 1,500 articles in Greenlandic in Wikipedia, tens of thousands of words. It's apparent to anyone who bothers to look at them that many of them were simply copied and pasted by people using machine translators because they're full of mistakes. Grammatical mistakes, words that don't even exist, inaccuracies like, Canada has 41 inhabitants. The corpus of knowledge in Greenlandic in Wikipedia is largely AI slop. And the speed with which this kind of slop is being produced is making entire knowledge sources now less useful than they once were. And I'm not sure what the solution to this is. There's the Internet Archive, there's the ability to do stuff, but what this should stress is that any systems you build that are going to be used for important things should be fed with curated data, preferably data you own to avoid intellectual property questions, but certainly data that you have an opportunity to assert is correct, is based on your reliable systems of record. Your COBOL and your Fortran don't go away. They're still producing the accuracy and precision of result that need to feed your AIs. A final thought. Eric Brynjolfsson at MIT has talked about the Turing trap. Alan Turing said if it can hold up its end of a conversation, a human conversation, and you can't tell it's not a human, then it's intelligent. And he said that, I guess, in the mid-1950s. And Eric Brynjolfsson said this has sent entire generations of AI research down the path of, wow, let's try to write something that can have a conversation. We have things that can have conversations. They're called human beings. Building something that uses massive capital investment to do a reasonable job of imitating what a person can do is maybe not the most useful thing to do. What about building things that do what we do badly or not at all? Here's one of my favorite examples. The current state of the art in competitive sailing is boats with wings on the bottom that lift out of the water and essentially are being flown by sails that look more like wings than like big billowy, poofy cloth things of old. And the tactics that this kind of a sailboat enables are different. So a simulator was built to help sailors develop these new tactics. And someone had the idea of, well, what if we run a few thousand copies of the simulator in competition against itself, against each other, I should say. And it started evolving novel strategies. And the next thing you know, the sailors are studying the behavior of the robot to get new insights. But the sailors still know stuff about the behavior of water and wind and about the limitations of the human crew. And the collaboration between the two is, to my mind, one of the paradigmatic examples of what it means to use AI correctly, to add to what people can do and give them tools to explore spaces that they might not explore spontaneously, either because they never knew it was possible or because they may have even had a conviction that it was not possible based on past experience. It is not about building machines that can do what we do and saying, wow, look at us, we built an AI. No, it's about entertaining multiple hypotheses at once. People do that badly. Even in a meeting of several people, the first good idea, reasonably good idea that gets put forward tends to anchor the conversation. And then the rest of the conversation is about improvements around that idea. Getting people to step back and say, well, wait a minute, what about a completely different approach? There may even be social pressure against that. People saying, hey, we're making a lot of progress here. Let's not start all over again. And Tom Malone at MIT at the Center for Collective Intelligence has studied this behavior. He said, we need to build tools that delay the moment of anchoring on one idea until we've really had a chance to explore the spaces that have been unconsciously or for other reasons barred from exploration. Now, the title slide was redefinition, so I'm going to give you one last definition. There's an expression that gets used a lot in conversations about stuff. about what people call technology, which is, complicated machines that they don't understand. That word gets, labeled, that idea gets labeled with the word technology a lot. And people say, oh, well, Murphy's Law, anything that can go wrong will go wrong. Like the other definitions I've tried to share with you, that is actually not the correct definition of Murphy's Law. Murphy's Law was an observation, and then you can go back and check the actual moment when it was coined, that if there's more than one way to do something, and one of those ways produces disaster, that's what people will do. That was Murphy's observation. That if there's two ways to do something and one of them is terrible and they're equally easy, people will do it the wrong way. And so you have to, but the point, remember, this is an active intelligence. It's supposed to guide future action and decision. The point is that you need to anticipate what people might fail to understand and design the system to make it difficult to do it wrong. When people say anything that can go wrong will go wrong, they're making a comment about cruel fate. They're saying, oh, well, the world sucks and we're just stuck with it. No, the correct statement of Murphy's Law puts the responsibility where it belongs, on the organizations and the individuals creating this stuff to anticipate and to guide user action so that the thing that you want them to do is the easy thing to do, and the thing that would cause disaster is really, really difficult to do. I mean, if you've ever driven a stick shift car, you know that generally speaking, they have to, it's hard to put it into reverse compared to putting it into the other gears, because putting it into reverse while moving forward would be catastrophic. And if we can do that on a stick shift in a car, I think we can do that on other things. This is about not saying the future is going to, crush me. This is about saying I'm going to be the foundation for that future. It is a future that's now. Everything that people were saying, 20 years, remember that the number on that Google slide that I showed you, machines have been demonstrating learning behavior for a while now, but now they're doing it at lower cost with greater accessibility. They're closer to the point of use. They're connected to more sensory input and more ability to monitor actual process. There's massive scaling up going on. At some point, it stops being a matter of degree, becomes a difference of kind. There are serious impacts right now on the ability of people who thought they'd followed all the rules, gotten a great degree from a reputable institution, acquired a useful set of skills, and they're saying, how come I'm not getting job offers? Well, because the things that you were taught were scholarship were actually behaviors that a machine can reproduce at higher speed at lower cost. What value will people and combinations of people add? Marcus Mossberger is going to talk about this at the summit. This is not job replacement. It's a redesign of how work gets shared between people and machines, like the example I gave you before of the sailing simulator. That is a wonderful opportunity. I am excited by it. I plan to, keep exploring this. I have not. I have left Salesforce, but I have not retired because the foundation is my full-time job now, and the opportunities of bringing forward the next generation of talent and turning existing talent into a new generation of collaboration, information, and intelligence is something that I just find tremendously exciting, and I hope you do too. And I appreciate the chance to share these ideas with you today. Thank you.
Peter, thank you so much. And I love this so much. I absolutely love how you always challenge us to think differently and to think critically. So really appreciate having you here today.
It's a pleasure. I think we were going to rely on the chat stream to be our source of questions. I don't know if anything's been coming in or if there's anything you wanted to explore further in the time we have.
Yeah, we don't have anything coming through yet, but if anybody does have any questions as we're kind of wrapping things up, this is absolutely the moment. So go ahead and use that webinar chat or use the Q&A. Raise your hand if you have a question. But I got to piggyback on what Amanda said, Peter. It's always so fascinating to talk to you. We love that you come back year after year and keep us updated because this stuff is changing so fast. It's really fascinating to think back on where we were just a few years ago and where we're going to be a few years from now. So thank you so much.
Someone said the other day that if you tried this stuff out a year ago or even a few months ago and formed opinions about what it can and can't do, those opinions are already based on out-of-date information. There are people saying, this is no longer, can it write a piece of code for you? This is, can you give it a description of what you want it to do and have it produce an application and then do its own stress testing and interactive testing of it and come back and just basically sign off on the result? That's a startling idea. Someone said, well, there's a reason why so much of the AI work went into writing code is that now they're writing their own next generation, and the next generation models are largely being written by themselves, and that's a moment of singularity, as Ray Kurzweil I think has termed it, where the machines begin to improve themselves at a pace that human engineers would not. It's a challenge because I forget who I'm stealing this from, but someone said when you write code, you're validating it in the moment of creation. You know what you wrote it to do, and you're thinking about that. If you are looking at code that was written by a machine, first you have to understand what it thought it was trying to do, and then evaluate, then do the debugging. Writing code, I remember saying 10, 12 years ago that code camps were not going to be the pathway by which inner city students from distressed high schools wound up being elevated into high wage careers. Any more than giving them driver's licenses was going to make them all Formula One drivers. If they were lucky, they'd wind up as Uber drivers. And I think I've been validated in that, but that doesn't mean that you don't need to learn to code. You do, because it gives you a specificity and precision of your thinking about, well, what are the limitations on the input streams? What are the errors that can be made in the process of calculation? It's important to be able, and this is a phrase I stole from Stephen Wolfram, to be able to think computationally, which is not the same thing as merely writing the code, but to look at a problem and see the structure of the computable processes in it. But that's now not that's no longer a product. That's just a step along the way to doing something that's actually interesting. So
Yeah, so
there's a lot of
Peter,
interesting stuff to do.
yeah, question for you. For those of us who do have kids who may be in middle school or high school and are starting to think about careers, like how should we,
Yep.
like, what are your thoughts there?
Um, there's a book that came out that was old when I was a college freshman called The Hidden Curriculum. That was sort of an anthropological study of MIT and Wellesley students more than anything else. And the title refers to the fact that when you're in elementary school, high school, if you do everything that's put in front of you and do it correctly, or a little, or maybe with a little extra credit thrown in, you'll do fine. The hidden curriculum at a school like MIT was therefore learning what you could neglect, what things didn't deserve your full attention because other things really needed it. That was the real hidden curriculum. High school students who graduate with AP classes and think they've been doing college level work have not really been exposed to that idea of needing to look around them and say, okay, this is something I can pick up and use as a tool. This other thing is just a pile of rocks, and I can study it, but it's not very particularly useful. Opportunities at a school like MIT are largely undergraduate research projects, and the classes are something you take as sort of a necessity of being there. We don't generally think of high school that way, but if you talk to students who are active in FIRST Robotics, or students who are in the Model Rocketry Club, or students who are doing a NASA Tech Rise project, where I know middle school students who have been collaborating around a table in a garage, integrating Python code with sensors to fly a payload on a NASA balloon, or to have something go up on a Virgin Galactic flight that's going to give them a couple of minutes of weightlessness in which to test using origami techniques on deployable structures. These are not things that are standardized exams. They are, here's a problem, here's a bag of parts or some other kind of budget. What can you do? And giving students that, where you find that also in programs like scouting, where you graduate from going through, the checklists of requirements to achieve first class rank or whatever. Once you get past first class scouting in the Boy Scout program, you're functioning more like a college student where here's the entire catalog of all the merit badges you might earn. Here are some of the requirements, but it's up to you to assemble the constellation of skills that are of interest to you, and then go find the merit badge counselors who will work on that with you. And it really is a great orientation to the difference between being a high school student and being a college student. So it's not necessarily about what subjects do you study, but what's the architecture of your learning, where you go from put it in front of me and I'll figure it out and do it, to I'm going to have to go find it and evaluate whether it is worth doing and assemble for myself the tools and the team. And that's the other critical thing about something like FIRST Robotics, is that assembling the team that can handle the stuff. Tom Brady said this once at a Salesforce event. He said, the difference between being a team that consistently wins Super Bowls or gets to Super Bowls and the other ones is that the best team, when you throw the pass, you're not even thinking about, is the guy going to be there to get the pass? You know he's going to be there. You know he's going to do his job. Cross training so that everybody can do each other's jobs gets a lot of play and conversations. The confidence in your team that tells you you can give 110% of your attention to doing your thing as well as you have to, because you just know the rest of your team's going to be there. If you can build that culture, and that's, again, I think something that Marcus Mossberger is going to talk about, because that culture now includes what we still call machine intelligences as well as humans, and really assembling those teams is going to be the defining human skill. The add of value. Where's the human value hide? To use the question that was asked at the beginning of the talk, the human value hides in the person who can create something that's more than the sum of the individuals, and that produces results that only that group could produce. And I realize we're at the end of our time. So
yeah, we do, and we do have one. We do have one. So first of all, there's some kudos in the chat for you, Peter.
Oh, great! Thank you.
They love this.
Happy to hear it.
They have found your rigorous way of thinking about AI to be very powerful. Great insights, great foresight. We'll end with one question, which I'm sure a lot of people are wondering. Gary was asking us, how do you keep up personally with innovation, with all the things that are happening? How do you stay abreast of all this stuff?
I cheat. I have 4 filters that go on the front of the fire hose on its way in. When something comes at me, I tend to say, is this about connection? Is it about collaboration? Is it about a challenge of computation? Is it about an opportunity for ex machination, for the automation? If I can look at something and say, okay, this is a connectivity story. This is about creating more capacity to connect. That capacity enables but does not guarantee collaboration. That collaboration is aided by, but not automated by, the availability of new computational capability. So understanding things like quantum computing, it's not about the physics, it's about what will it let me do that I can't do now. And then, all of that needs the leverage of machine intelligence. And so there are things that I've been looking at literally since 1985 that have been about, how can I take overwhelming quantities of bits coming at me, turn them into data by collecting them with purpose and giving them to people for a reason, creating an action of information by saying, this is what I want you to understand that you didn't understand before, because I want to have a conversation about intelligence collection, which is, so what decisions will we now make? That's to the extent that I do that. The other very simple technique is this: when you're reading an article about anything really important today, somewhere in the first paragraph or two, there's going to be some reference to some paper that's just come out or some researchers that they're quoting. Fine. Bypass the middleman or middlewoman author as quickly as possible. Just go Google that researcher's name, or go Google the title of that paper, read the abstract of that paper, and you will understand things that didn't manage to make it into the article in your business publication. Read Wikipedia pages from the bottom up. As soon as possible, go down to the bottom, look at the footnotes, because that's where the primary sources are. And you can essentially live in the future if you're reading the preprints of the next paper that author's going to produce, as opposed to the one that came out 6 months ago that finally made it into an article in the Wall Street Journal or Fortune this morning. So to the extent that it seems as if I'm staying on top of it, not really. I just cheat so that I'm living in everybody else's future.
Nice. Love it. Great way to close it out. Peter, thank you so much. This year and the years past, and hopefully next year, we love hosting you. We love your insights. Thank
I
you
can
so
pretty
much.
much guarantee there's going to be new stuff to talk about next year.
That's why we'll have you back, man. We need you to see into the future for us. So thank you so much.
Thank you for the opportunity. I always wind up learning things.
That's
Bye.
it. Oh, all right. Thank you, everybody.
Thank you.
Bye-bye. Have a wonderful day.